good afternoon, everyone. It's really great to have you here. Thank you so much for joining this webinar today. So as you already know, our webinar is titled Build Your Profile with Hands-on Machine Learning Workshop. And our special guest for today is Dr. Mamoon. So this is what our agenda looks like for today. So we're going to give you a little bit of an introduction to the webinar, which is this right now. And actually at the end of the webinar, we've got something special for you, and I'm going to pass it on to Tasnuva to tell you more about that.
Hello, everyone. This is Tasnuva. I'm the webinar coordinator at Aggregation. As you all know, at the end of this event, our speaker, Dr. Mamoon, will give you a take-home assignment. And when you send it back to us, you'll get a certificate of accomplishment. And the speaker will give you a Google Form link for the homework submission in the chat option. Please copy it to your desktop so that you can refer it back. But if you forget, don't worry. I'm going to send the link at the end of this event via email. Thank you.
Okay. Thank you, Tasnuva. So from there, we're going to get Dr. Mamoon to explain AI and healthcare. And then we'll have a short break so you can open up your different programs so that you can actually code with him, and he'll be coding in Python. From there, you'll get the hands-on project building experience, and then he'll show you how to add this experience from this webinar to your own resume. And from there, we'll have a Q&A session. So without further ado, let me introduce our speaker. So Dr. Mamoon Mia, and he's a project scientist at the Lawrence Berkeley National Laboratory. So his main work focuses on understanding earthquake hazards and risks in the San Francisco Bay Area, and he applies these data and insight for building a safer and resilient community against any earthquakes that could possibly happen. But alongside that, in his more personal life, he enjoys hiking, techno music, and meditating. So let's all give a warm welcome as Dr. Mamoon shares his knowledge with us.
Thank you, Rin. All right, can you guys see my screen? All right.
Yes.
All right, perfect. Yeah. So like Dean and Tasnuva mentioned, today's presentation is going to be hands-on machine learning model building experience so that you know how to build your portfolio in your resume and GitHub. So because GitHub is very important in tech job, people collaborate within team and outside team through GitHub. So I would like to also, some of you probably already have GitHub. People who don't have the GitHub, I suggest get your GitHub account as soon as possible. It takes a minute to open an account. And I will also send a link of my GitHub account so that you can download the data that I'm going to show after. So without further ado, let's begin. So content of this talk is, I'll start with a machine learning framework, showing how actually what machine learning is in one slide in a nutshell. Then I'll show what logistic regression is, because I'm going to use logistic regression modeling in today's heart disease detection, and so that you get a refresher, okay, what I'm doing, right? Instead of just doing something. And then, of course, the prerequisite would be Python. And if you guys have Jupyter Notebook installed, that would be awesome. If not, no worries. Finally, the idea is to show, like, after going through this, this is like a sample work project. And then after you go through this project building experience, you know how to build a machine learning project from end to end. And also, not only building the model, how to publish your results online so that other people can watch and view your results remotely. You don't have to send them PowerPoints. They can do it remotely as you are speaking, and sometimes they can change. They want to change some parameters. You can, they can update the models. So this is the good thing about, being now in Jupyter Notebook environment. And I'll show some other tools at the end of this presentation, how to include this, the dashboarding or API. Okay, so let's go. So machine learning, what is machine learning? We all are familiar, I'm guessing, because we have taken some math classes in high school or later. We know this function y equal to fx, right? So this is all machine learning does, to be honest. All sorts of sophisticated modeling, from linear regression to neural network, everything. The idea is this, y equal to fx. Now, what is this? So if in simple term, x, for example, you want to make juice, for example. So x can be, like mango, apples, yogurt, whatever you put inside the juicer, right? So this f of x is the juicer, the box, the juicer. You put everything and then you press the button, it gives you this juice. So you get the output is juice. An input you put, different type of fruits and other things. So this is just plain language that I wanted to explain to you guys that what machine learning does. Now there is different layer of sophistication in machine learning. Today I'm going to demonstrate one. So let's go. Here I added two terms, training and testing. So when you build a machine learning model, suppose you have data of 100 people. Now, when building a model, if you use all the 100 data set, you are not going to, how are you going to verify your model? So for example, if you use like 80 data set to build the model, and the next 20 data set, the remaining 20 data set, you can actually use to verify, hey, the model I built with an 80 data set, is it predicting the right results, right? So that's the concept behind training and testing. So you have to, you can build model with 100 data, but then you won't know if it is going to be the correct model. So that's the purpose of training and testing. Now, I'm going to use logistic regression modeling for today's project building demonstration. And this is a classification problem. You can understand, what's classification? Whether somebody has cancer or not. That's the classification, simple. Yes or no. It could be, so yes could be like if somebody has cancer, that is yes 1, or like we are encoding with these are called categorical variables. Yes 1, no 0. Now what I'm showing in this graph is that along the x-axis is the tumor size. So we know from our intuition, if the tumor size is bigger, generally it will be more malignant. So you see that the bigger tumor size, they are in the upper side here. So that means usually bigger tumor size is associated with more malignancy, more likelihood of cancer, right? But tumor size smaller, we would say less likelihood. So now, if we do a linear regression modeling here, as I'm showing here with this line, you can draw a linear regression line, and then suppose so at this point, if we make some projections on the x-axis and y-axis, this is the 0.5, which is halfway, right, in between yes and no. So it means all the data before this line here, this is actually showing the tumor size which is not malignant. So if you are in if somebody is in this zone, it won't be a malignant. On the other hand, if somebody goes, if the data point falls beyond this line, so that gives you this the tumor is more malignant. Now you can say okay, this linear regression is doing pretty good job here, right? It looks like if we do just linear regression through this data, we can predict this. Okay, if we bring any data, we can actually do some correct prediction. Okay, so let's go to the next slide. I'll show what's happening here. Now, previous case was this pink line, right? The red line, this data point. Now say your data point, you have one data point, which is really, really high, big tumor size, which is here, all the way to the right, you see. So big tumor size, so now, okay, and of course, big tumor size, it is malignant, most likely. So it will be on the upper side, not the lower. Now, if you do a linear regression now, let's now see the line, how the line performs. It goes slightly slanted, right? Even milder slope. So what's happening here now, if we do the 0.5 coefficient, like linear regression halfway, if we go halfway here, now all this data set, this before this vertical blue line should be benign, not malignant, right? But see what is happening. Like there are two data points here before this line, which are showing actually these are malignant. So this is not actually predicting correctly. So if you do a like blindly a linear regression model on this data set, you're not going to get correct result for this data set. You might get correct result for this case. This case simple. So linear regression, logistic regression, they're equivalent. Doesn't matter much. But for these cases, as the data set gets more and more complicated, you have to fit your model with more accuracy and more appropriate parameters. The reason I'm showing this is to you, not for only this webinar, if you guys appear for any interview, they will ask you what's the difference between linear regression and logistic regression. One big thing is linear regression is used for continuous variable, and the logistic regression is used for categorical variables such as yes or no, right? 1 or 0, or it could be multiple classification 0, 1, 2, 3, 4, and so, but if categories is too many, then it becomes more and more linear regression oriented. Okay, so let's go to the next one. This is something I'll quickly finish this one. I'm showing here that the linear regression does a good job for simple cases, but for complicated cases, for example, if we draw an S curve instead of a line, right, straight line, this will do a better job here, like it's shown on this plot on the right. So I will show further details in our real model. Now, I would like to just show you guys, like, okay, why I was thinking about AI in healthcare. Healthcare sector is being revolutionized by AI, especially, in some cases, the AI machine is like better equipped and better able to predict results with higher accuracy than the human. For example, you see here, according to a recent meta-analysis, machine learning algorithms do the job as well or better than human, whereas like 87% sensitivity and 92% accuracy, where human can do like 86% sensitivity, 90% specificity. So this is like, of course, not every problem, on certain problems. And then, Microsoft, we all know Microsoft is like, okay, they're pioneer in software, like Microsoft Office or like operating system, Windows. But even these companies like Microsoft, they are leaning towards healthcare in, building side projects like this. In our AI project, they're mainly gaining or building expertise in 3D radiological images shown on the right, as you see. So the reason I'm showing this to you, that some of you might like medical field, even if you don't have an experience. If you are, if you want to get involved in medical field with your AI expertise, you can easily get into that field, and this is going to be a big field in future. Now, so I would like you guys to go to this link. I will send into the text chat to download this data, and I will stop my talk here for now, and I'll let you guys have a few minutes break before I start the real machine learning project.
All right, so you'll be given about 5 minutes to set up everything, and then we'll come right back. Okay. And remember, the links are shared in the chat. So just open the GitHub and download all the necessary files. And if you're having any troubles, just let us know in the chat. Okay. So. So while we wait for the time to pass, what are some of the majors that everyone is studying, or what fields of work are you in? All right, so we've got software engineering and product development. I'm a PhD in environmental engineering. Wow, it's amazing. PhD in geophysics, business analytics, neurobiology, and development sciences. PhD in engineering and computing education, medical imaging. Wow. We are in a room of geniuses. My goodness. Personally, I studied communication but I could never, wow, electrical and computing engineering. That's just fantastic. Personally, I'm horrible at math, but good on everyone else. You are the future. Interesting. And if you'd like, why are you studying all these different fields? Like, what's the dream? Do you want to be the next big data scientist, the next big computer scientist? Okay. All right. So we've got less than 2 minutes. Please make sure that you are ready with your program open to code in Python. And I'm hoping that the link that was sent is working. Maybe we'll try to share it again in case anyone missed it. Yeah, there we go. In case you missed it, we've sent it to everyone again in the chat.
Yeah, please let us know if you face any kind of difficulties while trying to download it. So there are 2 files to download from the link.
Yeah. Okay. All right. Okay, as the break comes to the end, just a reminder, if you have any questions, please note them down so you're able to ask them at the end of the session to Dr. Mamoon. And enjoy your coding session now, and all the best. Back to you, Doctor.
Thanks, Dean. Hello, everybody. Welcome to my live demonstration of training a machine learning model for detecting heart disease using a logistic regression modeling approach. Now, I'm guessing most of you are familiar with Python, and some of you probably use Jupyter Notebook as well. So if you don't have Jupyter Notebook, don't worry. Please open the 2 files I gave you. One is the data file, which is hd-data.txt that contains the data, raw data. And the another is the Python script, basically, which contains the code, right? I imported that code in Jupyter Notebook so that I can demonstrate to you guys while I talk and what each code block does to basically do a logistic regression model. So are you guys ready? Let's go. So here we'll start with this Python libraries, as we're going to use these libraries.
Dr. Mamun, can we wait for another minute?
Yeah, sure.
Yeah, I think Sulov is asking for another minute. Too.
Okay, sure. I can wait.
Please let us know if you could not like download it.
Oh, okay. So zoom in. So somebody cannot see my. Better now, I guess.
Yeah, that's good.
Oh.
I think we can continue from here.
Cool. So we'll start with importing some Python libraries, as you might be familiar with the pandas. And since we want to do some plotting, we will use matplotlib pyplot plt as an object for plotting. We will also use Seaborn library for some of the data analysis. I'll show next. Now, you can use any style here. I used 538. It's a certain design of your website that used in Python. And you can use anything, basically. This thing is optional. It's up to you, this thing. But you have to import these libraries. So let me know if you guys are following me or if you have trouble to follow me. So you have the Python script, right? You already have the script. You don't have to actually code also. I want you guys to understand what each code block does so that you can do it by yourself. You can run, of course, the Python script I gave you, but that's not gonna explain everything. Now, we'll start with opening our data file in pandas data frame, right? So df equals to pd.read_csv. So we'll read it as a CSV data file, which is hdata.txt, which you already have. I'm guessing by now you should have this file already. Now, how the way Jupyter Notebook works, I should tell you. Let me give a little introduction about Jupyter Notebook. So when you use Jupyter Notebook, open a Jupyter Notebook, it looks like this. And this file you see here, this is a local directory in my computer, which has these files. Now, if you want to create a new Jupyter Notebook, you can go here on the right, new, and you can use any of the kernel. I have different kernels in my local machine, so I will use Python 3 here. So this is what an empty Jupyter Notebook looks like. And as you see, this is called a cell, and this is like IPython convention. So let's say I'll just quickly show you a demo. X equal to 5, y equal to 3. Now x plus y. How it works, I'm just showing this, how this kernel works. Now, so x plus y should give you 8. How do we run it? So there is a button here on top, you see a run. So if you run, it should give you output 8. See, so out 1 equals to 8. As soon as this command is run, it is going to the next command, right? It is asking you, what else do you want? So this is how Jupyter Notebook works. And you can type in any complex code, the one I was showing here. So the way I'm going to run this code block is, okay, so as you see, as soon as I press on this cell, it is called a cell, one block. So this cell becomes green, that it is ready to run. So let's run this. Run, nothing happened because we didn't ask for anything. We just said that, okay, import these libraries from Python, pandas, blah, 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 and it is importing this. Okay, and the next block, which is, so next block is ready to run, right? So we have code df equals to pd.read csv. So to read this file, and df.head, this is a Python convention, data frame like pandas convention. When you pass in this command. Okay, so if you can follow me with a new Jupyter notebook, that would be great. You can learn the most. If you cannot, just use your local Python editor and run locally on your machine by running the script. I'm sure some of you can run the Jupyter notebook with me, so please do. I think that will be the best. So df.head will print out the data file, not the entire data file, first 5 rows of the data file. So let me show you how the data file looks like. You already have it, but I will show you again. You see here, the first row of the data file, it shows the labeling of the field, right? What features the data set has. Age, sex, CP, these are like all medical terms, cholesterol, resting EKG, thallium, and angina, blah, blah, blah. So you have all these variables here. And you have finally last variable, which is called target. Target variable is which is the output variable. As you see, this is the value of the target, the last column, right? So all the way it shows all 1, 1, 1, 1, 1. But if you go towards the bottom, it shows all 0, 0, 0, 0, 0, right? The very last column of each row. So 1 means the patient has heart disease. 0 means patient doesn't have heart disease. So these are 2 just categorical variables, not continuous. So this is another reason we are going to use logistic regression modeling. Now, okay, so we have some understanding. We see that, okay, age is kind of like, okay, we know a typical age of a person could be here from 20, 30 to 60, 70. Then I'm just showing some values here to later I will show you that this data needs to be transformed so that we can use modeling in a way that gives us accurate results. So without further ado, let's go to the next step. So I mentioned this df.head should give you the first 5 rows of the data set. Let's run this. Okay, so the way you run it, you click on this cell and then run. Okay, it's running. The IPython ran, and you see this. It gives the label, right? Each field. Corresponding to each field, we have the data first 5 rows. And Python starts from 0. So 0, 1, 2, 3, 4. So 5 rows here. So if you can check your data file that it is reading correctly or not. Let's see the first row. First row, zeros. So first row is like 63, 1, 3, 145, 233. So this row, basically it is going to. So it's a check. You can do the, if my Python code or Jupyter notebook is reading my data file correctly or not. So this is a good practice. Okay, once we do that, okay, we see this is loaded properly. We'll go to the next step. So machine learning, building machine learning model is.
I'm really sorry to interrupt, but can I ask a question here?
I would prefer at the end, but go ahead. Anyway.
No, it's about the Jupyter notebook. So could you please go back to your Jupyter notebook host, like local host, where you have all the files?
Oh, that's like GitHub, right?
No, in the Jupyter notebook.
Oh, yeah, here
is the home page.
Like, give me a second. Yeah.
I think the previous one.
Yeah.
Your home page.
Right.
Yes. So how did you open that heartdisease.py in the Jupyter notebook as?
You cannot. You can. Jupyter notebook is the file extension is .ipynb. IPYNB.
Right.
This is the file. Do you have it? You don't have it. So
no,
what you can do?
Not.
Okay, so no problem. I'm saying what you can do. Let's see. So you see on the right side, new.
Yes.
Click on the new, and below new, you see the kernel. Do you have Python 3?
Yes, I do.
Okay, click on the Python 3.
Mm-hmm.
Does it open a new notebook?
Mm-hmm. Yes, yeah, I do have that.
Okay, good, great. So now you can copy and paste from your Python script on the cell. and run with me.
Oh, okay. So I have to just copy and paste. I was thinking
Yeah, I
about,
mean,
like, if
you
there's
can
any way to
type
open
in
the
if you're
file.
fast. No, you can type in actually. You should type. Then you will have better practice.
Okay, all right.
Yeah,
Anyways,
do
thank you.
whatever best because I have limited time. I'll have to go through this, right? I'll have to
Okay.
show you the complex part of the model. But you got the idea.
Yes, I do. Yeah, thank you. I was thinking, like, if there's any way to directly open that file in Jupyter Notebook as a complex cell.
Yeah, so
But seems like,
here you got it.
yes, I got it. I think I can work it through.
Awesome, great.
Thank you.
Let's move on to the next part. All right, so we'll usually discuss the questions at the end, but if it's really urgent, you can type in the text then in the chat box. I'm looking into it. So next step in our model building process is called exploratory data analysis. Now, this is not only for this model, any machine learning model, actually not only machine learning model, if you build any other model, mathematical model, I mean, you want to check your data. If the data looks okay, what is the pattern in the data? What kind of variables, like what extract, like important variable, not all the variables may be important for your case. Some variables are there for the purpose of acquisition of data, but we may not need to use that feature for our model building. For example, what I'm saying is, like, for example, maybe, cholesterol is important. Maybe FBS or sex is not important for this. So we don't know. So we'll have to do some exploratory data analysis. And doing that, we'll know, okay, so what to do to the next step. So let's go there. So what I'm doing in the next cell here is like generating descriptive statistics. That includes, when you calculate the statistics of a data set, you get mean value, standard deviation, and some percentile values, 30th percentile or 70th percentiles, so that you know, okay, what is the central tendency of the data? Is it normally distributed, or is it like no, or are there any missing values in our data? Okay, so let's run this cell here. Now, when I run that df.describe, this is the command, right? And this is the line on the top is the formatting, like how you're formatting your data. Okay, so let's go to, so df.describe is giving us this table here. Now, what is this table doing? We saw this, we have these features: age, sex, CP, cholesterol, resting blood pressure, blah, 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 all these things. Here, this count means how many data, how many number of data set, basically, number of people we have. That's total 303 data set, rows of data. If you check your data set, you will see that there is a total of 303 rows of data. Now, when you do the df.describe, it automatically calculates the mean value. Okay. So for example, mean value of the age section of all the 303 data we have is 54.37. So you get an idea, okay, it's mostly probably older population, right? Not younger population. The age is not like 20s or 30s. We kind of get some idea, okay. Usually people who are older, they are more likely, more prone to heart disease. As we get age, our propensity to get sick from everything, including heart disease, gets higher. Standard deviation. So what is the standard deviation? Plus minus 1. And then minimum value of that. I'm just talking about one field, age. It calculated for every feature here, as you see. For example, one thing is, you notice here, the sex. I mean, what is the mean value of sex? This doesn't mean anything because sex is categorical variable, either male or female, right? In terms of our data collection. Okay, so, but it is giving you some value, but in our case, I mean, this doesn't make sense. 0.68, does it mean male or female? We're not going into the gender spectrum discussion here. We're just sticking with, male and female, binary. But other things it's giving you here, 25%, 50%, 50%, and 75% percentile, because this is something also important to know, like your measure data, like for example, to 47, like 47 years old and lower, they fall into the 25 percentile of your normal distribution curve. Okay, 50% is 55 and 75% 61. Similarly, all other variables have the same percentage. So this gives you an idea of actually to see for each of these feature, what is the mean value, what is the maximum value, what is the standard deviation, and you kind of get some idea ballpark in your head before proceeding further, right?
Hey,
There's a
Mamoon.
question.
Sure.
There's a question from Sulaf. He or she is asking.
Oh, it's a txt file. Don't worry about I mean, the formatting inside is CSV, but the extension is called txt.txt, htdata.txt.
Is the current file being shared to in GitHub that you are sharing?
Yeah. This file, this Jupyter notebook, I'm not sharing. I want you guys, this will be the homework I will give you guys later.
Okay.
Because I'm not going to give you, I mean, this is a part of the process. When
this is a solution.
I'm giving them, I'm giving you the Python script. I want you to learn how to use Jupyter Notebook and also how to publish your results from Jupyter Notebook to online so that your team member or other people, for example, or the hiring manager, you want to share your Python model, online, you can send him a link. You'll just click on the link, he will see all the models and results and everything. So that's the crucial part. You can find a lot of Python script and solution everywhere, but the important part is to how you demonstrate your skills, how you express yourself, how you talk to the interviewer. So that would be the crucial part, and I want you to for the take-home part, you will build this Python Jupyter notebook by yourself. But I am giving you this code, and I'll show you at the end of this model building how to publish it in a platform called Voila. So that's something you need to know. For the homework you will do, submit that.
One more thing. If you have a question, please write it down in the chat, and we'll be answering your question from there.
All right, guys, looks good so far. Let's go to the next line. This cell, which is df.target.value counts. Let's see. So what I'm plotting here, like target, if you remember, open the data set. The target value has 1 and 0. If you remember, this is the last feature, which is 1, 1, 1, 1, 1, and towards the end, all 0, 0, 0, 0, right? So 1 means the person has heart disease. No, 1 means doesn't have heart disease. 0 means have. 0 means absence. 1 means presence. Let's go. Now we are going to plot that with red and blue. Let's see. It's like bar chart. So let's see what is it doing here. 1 is having heart disease. 2, 0 is no heart disease. So it shows in number of counts. So we have, if you remember, we have about 303 data, right? Row of data. So among this 203, I have we have about 160 or 70 which has heart disease. If you count from the file, you can match if it is okay or not. And then blue, which doesn't have heart disease, is more or less about 135 or something, or 40. So this gives an idea. Okay, instead of you go manually count, right? You would do a fast bar count, like how many people have heart disease, how many people don't have heart disease. This is a quick check. Next line is, let's say we want to check the missing values. Like this is a small data set, but if you have a data set, a big data set, like this is small, you can probably quickly go through by naked eyes, and you can see, oh, okay, no, it looks good. But the data set could be huge. Then you have to use some function. For example, here I'm using df.esna .sum. If you use this, it will give you, okay, it's saying no missing value, 0, 0, 0, 0. All these variables have values. There are no missing values in any of the features. So that's perfect. If they have missing values, we would have to go there and then fix them. So either you fix with your knowledge, and if you don't have the sufficient knowledge, you have to throw out that data, because otherwise it's going to contaminate your model if you just blindly use any data. Now, having said that, in this cell, I have created two lists. One is categorical, another is continuous value. Now, if you see in the, again, I'm showing this data file here. 1 and 0. This you can put it in categorical, right? Category is like how many different classes are there. 1 and 0, 2 classes, but there could be 4 classes. There could be 5 classes. 1, 0, 1, 2, 3, 4, 5. But there could be some values which have like probably hundreds or 200s, 300, thousands. We won't categorize them as categorical variables. We'll call them continuous variable. For example, age we'll refer it as continuous variable. So let's see. We are creating two lists, categorical and another is continuous. And I'm making a for loop here and putting the for loop through the columns of the data frame. How many columns we have here? If you notice, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 columns. Out of 14, some of them will be categorical, some of them will be continuous variable. And I'm putting some formatting here. And now I'm putting a definition here that if column uniqueness is less than 10, for example, 0, 1, 2, 3, or 0, 1, or 0, 1, 2, 3, 4, 5, 6, up to 10. If it is below 10, I'm calling them as categorical variable. If it's up to you, you can, so this is also another thing, like it's subjective, it's not like objective thing. You can probably say like, no, I can go probably 12. Yeah, you can do that, 12. You can, but you cannot do like hundreds because that's not rational. So now if the values are less than, the unique values are less than 10, we are calling them categorical. If the values are higher than 10, we are calling them continuous value. And I'm saving them in two lists, which you're going to show here. Now, as you see, the age, see, so age is a continuous variable, right? See, it's more than 10, as you see this list. Sex is, for this purpose, only binary here. But in general, sex is also not binary. We are not going there. But here only 1 and 0, male and female. CP, chest pain, they have 4 measures, 0, 1, 2, 3. So they have certain connotation. So this is also a categorical variable, right? Because we defined here below 10. And the blood pressure, cholesterol, all these things, these are, look at these values, are all these unique values here, right? As you see here, up here, I defined if unique values. So these are all unique values. If the unique values are longer than 10, this is going to be continuous variable. So we ranked our features in two partitions. One is categorical variable, another is continuous variable. This is the purpose of this block of code here. Now we'll do some plotting. In this case, what are we going to plot? So I'm defining here that I'm going to plot the categorical value. So categorical meaning here, as you see this value, target is the output variable, thallium 1230, CA, whatever it is, slope, all this, it is going to plot all this categorical variable, not this one, not thallic, not cholesterol, not blood pressure. These are all continuous variable. In the first layer, I'm going to only plot this categorical variable and target equal to, so I'm plotting target equal to 0, meaning no heart disease. And I'm labeling them here, as you see, no heart disease, because we know already 0 means no heart disease. And target 1, which is heart disease, and which is I'm going to annotate them with yes and color red. So with that, so it's a for loop, as you see, it's 3 right? So however many I column in enumerate, I'm guessing you guys are familiar with enumerate, right? So in a list, what enumerate function does, if you have a list of 5 elements, enumerate gives the value of the list element and the index of that element. Index value is in a like a point coordinate. So for this categorical value, it's going to do some plotting. Let's create the plots. We're gonna have to wait for things. Here it is. Now let's start with the first plot. So like I said, we are plotting the categorical variables. So let's say first categorical variable we have noticed here is the variable sex here, right? Only 2 values. So we'll see with the 2 values means like 1 probably male, 0 female. Now we want to see like how many males have heart disease and how many males do not have, and how many females have heart disease and how many females don't have disease, right? So here you go. So the first plot, it is showing in terms of bar plot. So 0, we say female. So basically on the y-axis, it is showing the number of people, how many counts. So here you say around 70 female have heart disease, about 25 don't have heart disease. So you see this darker red here, this is actually blue, but this bar is plotted on top of blue. That's why you see this darker color. Okay, so blue, this blue color here is the no heart disease, 25 people. So this is for female, right? 0. On the right, it shows for the male, because we have only 2 sex here, 0 and 1, male and female. And then 1 corresponding to male, and see how many cases, more than 120 or 30 have heart disease, less than 100 do not have heart disease. So these are like a way of displaying your data, giving some idea, getting some idea, like before you build your actual model, what is your data showing, right? And if you want to do other investigation on chest pain, CP is chest pain, there are 4 different levels of chest pain, 0, 1, 2, 3, 3, and it is showing in a similar pattern, the way I explained for the sex, the same number here. So how many categorical variables we have? Let's see, we can count here actually. Sex, CP, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 categorical variables, meaning 9 features have values less than 10, right? Because that's how we define our categorical variable. So we'll have 9 plots here. So 3 on the top, 3 in the middle, and 3 in the bottom. So 9 plots we got, and we see, okay, this looks good. Number of, it gives us idea. So for example, in your not only model building, if you want to do some pre-processing, or like you want to show some additional information for your report in your job, like in your job is not only giving some model building. When you climb up the ladder, you will also have to write a report. So when you write a report, you can provide these plots before the actual model, and then tell them like what this plots means and how this helped the model building process. So this describes a little bit the meaning of. So guys, please let me know if I should go a little slower or my pace is fast for you.
Dr. Mamoon, there was a suggestion from one of the participants, like, can you go a little bit slower?
Okay, sure.
Thank you.
I'm just becoming mindful of the time, but yes. I guess it will be okay. So
thank you.
We plotted, they had actually the Python script, so if they can follow my voice, that would be, I think, important. So here, the second part. So in the first part, we did the plotting for the categorical variables, categorical features, right? Now we have also variables, the continuous variables. As you remember, in this code block, we created 2 lists. One is categorical, another is continuous. So continuous variable, which are these? These are age. Age is one continuous variable, right? It has more than 10 unique values, as you see, notice here. Blood pressure, resting blood pressure, cholesterol, these are all continuous variable. How many we have? 1, 2, 3, 4, 1, 2, 3, 4, 5. Let's say we have 5. So let's plot this like the categorical variables. So I have this code. I'm guessing you all have this. You all have the access to the same code, right? Not the Jupyter notebook, but if you have the code in your Python, in your computer, you can open an editor and paste this all codes and then run it. And you will see all these plots that I'm showing you. Let's run this block here. So you see, it takes a couple of seconds to run. Now you see, what is the difference between these plots and the plots before? Plots before, we have distinct numbers like 0, 1, 2, 3, 4, right? Only category, 5 categories, 3 categories. So categories less than 10 are plotted above, but categories which are more than 10, for example, age, this is definitely not categorical variable. So it's a continuous variable. So I plotted, say, in similar way. Blue, no heart disease. Red, heart disease. On the right plot shows the T-rest BPS, the resting blood pressure. Resting blood pressure, blood pressure we know typically ranges from this. The high pressure ranges from 120 to 180. I'm showing it here from 100 to 180, right? So you see that most of the blood pressure lies in this zone, 120 to 140. From here, you can kind of see like if there is any correlation between heart disease and blood pressure, right? For example, if your blood pressure is 130, you see, yes, like, yeah, there is a big peak at 130 blood pressure. And we see the this red line, huge spike. Compared to if you have blood pressure 100 and if you have blood pressure 130, we see a big difference. So we get a sense of the data that, oh, if the blood pressure is in this range, there is a more likelihood of becoming infected with heart disease. But it's not necessarily true for higher blood pressure. For example, look at this value at 180. Like, I mean, we might think like, oh, if the blood pressure is high, maybe heart disease propensity would be higher. It's not true. I mean, I'm not making this up. This data is showing that blood pressure higher always doesn't mean everything. So there are other factors here, obviously. Now, this 180 doesn't not necessarily, there are some cases, but you see the majority of cases fall between 120 and 140. So this is basically, this is the purpose why I'm plotting these variables with heart disease and without heart disease. Similarly, with cholesterol level, you see that when we have cholesterol level close to 200 to 300, we have a high concentration of heart disease, showing by the red bar plots, right? But if you notice, we also don't have, there are also cases which don't have heart diseases, but number of cases having heart diseases exceed far more than the cases that don't have the heart disease case. And here on the right, another variable is thallium, showing similar. Here it's interesting. You see that with increasing thallium concentration, it shows that the rate of increase of the heart disease. But towards the extreme, it's not much actually. If you see too much, not much. Now that's all. That's all about the descriptive statistics of the data, right? You can see that, okay, what variables are important, what variables at what range they fall, and what is more predictive of heart disease, like ballpark. You're not predicting accurately, you are just having some mental picture, mental model, we call this. So before you build your actual model, you made your mental model. Okay, so what does darker red color in the plot means? So darker red colors is actually, it's fallen behind the red color. That's why you see the darker red. It is actually the blue one. So blue, so the one you see in the background, these are blue.
Oh, okay, got it.
Yeah. So that's why it looks like, because we made some transparency. That's why it looks like. If you don't make transparency, you see here, alpha equal to 0.6, right? You will see, you can play with this in your script. the script I gave you, you can make one alpha, and then you'll see everything is red, or some blue will be shown here. You will not see the background transparency. Okay. Great. Now, yeah, thanks for asking. You can ask questions in the chat box. I'll notice and answer in the whenever that is allowed, whenever it's appropriate. So you got an idea what the features are. Are these features correlated with heart disease or not, right? With blue colors and red colors, because these are categorical variables. We can easily demonstrate that. Let's go to the next step. Create another figure. Let's see. So let's plot this. I'll describe with the plot. So let's say we are plotting here. Along the x-axis age, along the y-axis maximum heart rate. So we want to see the cross correlation. We call it in scientific term cross correlation. So if there are two variables, maximum heart rate and age, is there a correlation of heart disease and no heart disease, right? For example, okay, let's first turn this off. Let's turn this the blue one off, and I'll rerun this. You can go up and run. You can put a hash sign in front of this line, and I'm turning off this line, so it will only show the red scatter plots. Let's run this. Okay.
I don't want to interrupt, but we have 30 minutes left.
30 minutes. Okay, sure. I think I'll be good in 30 minutes. So guys, I want to show you this the correlation. Do you think there is a correlation here? I mean, it's not all jumbled. I can see that there is a trend. As you go from left to right, there is a downward trend. If you do a linear regression, there will be a line diagonally from left to right, from top to bottom, right? Here. So that means with increased age and lowering heart pressure, you have more heart disease. With increased age and higher heart pressure, for example, you don't see any heart disease here. It's white space. You see heart disease here, which is like lower heart rate, 120. We don't have like 200 or 180 even. We don't see this. So this is telling you something that, okay, with increased age and lowering heart rate, we have some correlation with the heart disease. Okay. So similar correlation you can notice for the blue one. I'm just turning it off on again and then rerunning it again. So
there is a question from Barnaby Rashid.
Should we check for collinearity between variables? In this case, well, you can do collinearity. You can do a collinearity. I'll show you how to do that in a while. You don't have to do individual collinearity. I'll explain it in a while. So, okay, let's go to the next. Since she here asked about Barnaby Rashid asked about the collinearity. Let's talk about collinearity now, okay? So collinearity means like, okay, if we plot two variables, x and y, and then we see there is a linear regression, if we plot a linear line, there is a, there is a good correlation between these two variables. We call them, they are linear, more or less linear. Now we have more than two variables here. We have 14 variables, right? For this kind of thing, we do what is called correlation matrix. So we can plot all the correlation coefficient in one matrix, and you can see, okay, which correlation coefficient is important, which variables are important in our case. So the way you get it, correlation matrix df.core, and then the command is sns.heatmap. That's the Seaborn library, SNS, and heat map. You plot a heat map. Let's plot this and see how it looks. Here you go. Now, this is a nice thing I wanted to show. Okay, so what it shows, like along the x-axis, along the y-axis, same variable is plotted. You see the age, sex along the x-axis, and same thing here, age, sex from top to bottom. Now, obviously, if you notice that this is target here, and on the y-axis, this is also target here. So that means this variable. So correlation between the variable itself is 1, right? What is the correlation between x and x? 1, because if you put this point will be at the same place, 1, 1, 2, 2, 3, 3, if the value is same, right? So diagonally, you will see this always 1 correlation matrix, because diagonally they are correlating with the same variable. For example, if you go to this one, go vertically down, which is thallium egg, go horizontally left, which is thallium egg, right? So that means the variable is correlated itself. Now, the important thing is, okay, now we understand that. What is the other thing showing here? Now, that's a good thing, right? Let's say, for example, explain this one, the 0.42. So 0.42, let's go to vertically downward from here. Vertically downward, we have target variable. We have, if we go to horizontally left, we have thallium egg. So this is basically showing you the linear coefficient between this thallium egg and the target variable we are interested in. So meaning that what is the correlation between thallium and our target variable? Meaning thallium and having heart disease or not. So it looks like there is a good correlation, 0.42, not bad. It is showing with darker color. But if you go in like 0.34 or even less, there are some even less, 0.28, 0.1, right? 0.15. So there is even less correlation. So from there, we can kind of get an idea like which variables are important for our model. So for example, thallium would be a good predictor for heart disease. Another would be 0.35 slope of the curve they get from the medical testing. Another would be CP, chest pain. Chest pain, angina is associated with heart disease. So this is so you don't have to do one-on-one correlation. You can do heat map in order to get an idea of how the features or independent variables are correlated with the target variable here. So now we are dropping the target variable here for this one because this target variable is the output value. We want to see that correlation with the target, how it looks like. So df.drop correlation with the target. So target, we want to see how these features are correlated in bar plot. I was showing you the value here, right? 1.35, 0.39. So see these values are plotted here. So from here you also see, okay, maybe these variables are also important. This showing higher value. So let's go quickly. We don't have much time. We'll go to the next step. Data scaling and standardization. After the exploratory part of the data set, we need to do some standardization of data because our data is not all categorical. It's not all 1 and 0. There are values which is like 150, 187, or age, which could be 50, 60, 70. So we need to scale this data in a way, making it more close to, bringing it more close to with target variable, which is 1 and 0. How can we do that? We can scale them, right? It's called standardization. So one way is to do that is called standard scalar. It's a scikit-learn library. You can import this standard scalar. And once you standard scalar bring that, what it does is like it subtracts the median value. For example, age has median, say 57, mean value. Now you subtract the mean value from each row and then divide by the standard deviation. If you remember in the beginning, we calculated these values right here. Mean value 54, standard deviation 9.08. And if you do that, once you do that, and if we print this, we'll get, see this age is no longer showing this value, 57, 61. Age is no longer showing that value. And we want that because we want these values close to 1 and 0, right? So 0.95 close to 1, minus 0.1.92 is close to 1. It's not like 57 or 60. The closer you can bring them, the better your model will become. Because there is an algorithm called gradient descent, if you are familiar with that. Gradient descent doesn't converge well if your data features are in different dimensions. So let's go to the actual logistic regression model, which is very simple. So for this part, I will start defining a function, helper function, which is going to print its score. And I'm defining this as a classification model, X train, Y train, which is like a training data set, right? So training X data, training Y data, and X test, Y test. These are tests. After building your model, you want to test your model with this data that your model is being accurate or not. So train true. Okay, first we're going to train the model first. So that's why I put train true. Now, if we want to, after training the model, if you want to run the testing case, we will put train equal to false. Prediction equals to classification.predict. So this is all coming from that scikit-learn library. Okay, you guys can use this library, and you can classifying report. These are all the classes that Python library built. Logistic, you don't have to build logistic regression from the scratch. Logistic regression is already built in Python. You can use the library, but the underlying assumptions you guys have to know. In the beginning, in the PowerPoint slides, I showed you guys what logistic regression is and how it works, right, compared to linear regression. So, and the other things are basically the messages you print out after each. Now, let's go to the, so that was a function. We haven't done, sorry?
Dr. Mamun, the gentle reminder, we have 8 more minutes to go for the question.
Okay, perfect. All right, I'll just quickly run through this. So sklearn, model learn. Okay, so this is X data set drop target. We are dropping the target data set because we want to train the model without target. Now X train, X test, Y train, Y test is that train, test, test, split. We are splitting the data set and test size equal to 0.3. That means 70% data is going in your training, 30% data is going in your testing. So with that, let's run this. Okay, let's run this. So this is a function, so it's not going to do anything because function is not being called yet. Here, this is also not going to do anything because we haven't requested anything. We are just dividing the model, like we are just classifying it. Here is the actual part where the model is going to calculate the logistic regression function, solver linear by linear, and linear classification fit, X train, Y train. So once you do that, I am printing score, linear correlation. So logistic regression classification, X train, Y train, X test, Y test. I'm printing this. Let's print this and we'll discuss that. Now, okay, train result. See, if in our helper function, we have that test result, accuracy score, classification report, confusion matrix, right? So we all have this value here. It's doing accuracy score 87%. Classification report, it prints out, it will automatically print out all this for you. All right, so once we do that, we know our model is built. It's not tested yet, it's built, right? Train. So X train, X test, Y train, Y test. So here in the second part, test result, we also do the test because our helper function has two parts. One is train, first part, and the second part is the test. So in the testing segment is here. So it's a testing is accuracy score is also 87%. So which is pretty close. I mean, 87% is pretty good. And so we are happy about it. We'll go to the next. Let's see final result. Accuracy score, and this we are making it with 100, multiplying by 100. And then let's printing out that. So basically our final model showing that logistic regression model built with training accuracy 86.79%, testing accuracy 86.81%. So this is the end of this part, but I want you to understand this. Okay, you have this code already. I want to show you how you're going to publish this data to your team members. This is an important part for landing a job. In the interview, if you can demonstrate these skills, the interviewer will be impressed that, okay, you not only work in, do coding, you know how to communicate with other team members who are located remote places. You can just send them a link and they can view the results. So here is a tab called Voila. So if you use Jupyter Notebook, it doesn't have this Voila. You have to install it separately, okay? So Voila, you install it using pip install Voila. You can find online or YouTube how to install Voila. You install Voila, okay? That's your homework task number 1. Actually, task number 1 would be GitHub. Who doesn't have GitHub? Second task would be creating a Jupyter Notebook. I'm going to show you the slide again. And the third task could be the Voila, how you're going to present your result in Voila. So click here. So it's executing. It is reproducing all your results. Okay, the results that we just showed, we created. We are gonna demonstrate it in a local website. You see that it's what is showing: localhost 8888 voila render HD prediction.ipy unv. So your Jupyter notebook is now being converted into a dashboard. Look at this, how pretty it is now. There is no code. Suppose your boss asks for the result only. So you just send him this one. You send him the link. You send him the link. He gets like, oh, this looks pretty good. It doesn't look like any Python or Jupyter or anything, right? So this is the good thing about having a Voila. So I want you guys to use that. So with that, I'll get back to my PowerPoint slide. And before that, now I want to tell you about the resume section. Okay, so now that you build this machine learning model, right? How are you going to present this in your resume? Now, see, these days the tech people, they want you to have GitHub portfolio link. So people who don't have a GitHub account, open an account today, and you can just paste it here. Even if you don't have anything, just paste it here today. So you have the GitHub account right away. Then summary objective, you say skilled machine learning engineer with expertise in like say medical data process, medical data, heart disease, let's say medical data analysis using machine. We'll write details in later. Successfully measure machine learning accomplishment. Successfully implemented. If you guys following me, I'll send this to you guys, this resume template. Okay, what I did in 1.5 hours, you can basically build your resume, the machine learning component. So implemented logistic. How much time we have, Tasnova?
We are almost at the end. We should start taking questions now.
Okay, so guys, I will send it the template to you, and you see how you're going to fill this out in the machine learning the resume section. So I'll transfer it to Tasnova and Dean.
But there's a question. So yeah, the first question is, can you please explain the confusion matrix?
Yeah, I'll do it. Tasnova first. Let finish with the other tasks. I'll stop sharing. Okay. So Tasnova, you have something about the homework. Can you tell them?
Okay. So I think Dr. Mamun will be sharing a Google Form link in the chat option with all of you, and just send the homework to us. And when you'll be doing that, we'll give you a certificate of accomplishment. I believe you'll love that. And yeah, so Dr. Mamun, do you want to like share the link?
Of the Google form, right?
Yes, please.
Yes.
And also, like for all of you, we'll be sharing this recorded session with all of you. So don't worry if you missed anything.
Okay.
Finally,
all right. And while we wait for Dr. Mamun to put the link in the chat, we just have one announcement. So at Algorithm, we're going to be starting a workshop where we're going to be helping people we're going to help you with your professional writing. And this is a gateway to attract recruiters and attract them to your profile and what you have to say. And this is going to start on April 18th, so 2 weeks from this webinar. So if you are interested in signing up for this, we'll be sharing this link with you as well later on. And is Siam still in the, okay.
So send the form link. Okay, guys.
Perfect.
So
Submit
please
your homework.
save the link. Please save the link. It is on the chat and the chat option.
Yeah, I just did.
Yeah.
So be sure to save that link, as well as this other link that I'll also be sending you to sign up for the writing workshops. Okay. And Siam, if it's possible, you can also mention a little bit more about this workshop and what to expect.
Sure. Hey guys, jumping in, could not be in the whole session, but hopefully this was good. Am I audible?
Yes.
Awesome. So, hey, so hopefully you guys enjoyed the session. Obviously there will be some more, I think like Q&A near the end, but I just wanted to let you guys know that we are starting a new cohort primarily on the data science / machine learning track. We'll bring in industry mentors. One of the mentors is Mamun. We'll bring in few more. And basically, there are two things. After the session, if you want to, just go to the Aggregation website and apply. And then basically, Dean will give you a little bit more details on text on what to expect on the industry exposure writing, which is basically that we are connected to some of the employers in the industry. And essentially, after you finish that professional writing context, you'll basically you'll get more exposure to the industry, and we'll basically pass your resume to the employers we are connected with. So a lot is loaded to give a quick short, tell it in such a short time. But what I'll do, I think the best way for you guys would be just going to the website and applying. And if you can just talk to us in meeting, I think that will be easier to do one-on-one. And then maybe Dean, you can also give some of the text of the industry exposure series we are talking about. So you can give some of that link. So yeah, that's all I wanted to say. Good luck. And let me just see if there is any question for me in the chat. Okay, good question. I think there are some Q&As coming up. I'll let you guys handle those, but most of the communication can be handled by email for homework Q&As, that I can say. But that's pretty much it. That's all I wanted to say. I'll drop off. But Dean, are you good? Dean, Tasnuva, and Mamun, are you guys good from my side?
Yes.
Awesome then. Yeah, sweet. All right then. Good luck.
So we have a very important question here from Bunny.
Yeah.
Who should we contact if we face any problem with the homework? Is there any deadline for the homework?
I mean, it's up to you guys. I would say finish it by this week, like by Friday. Send it. It doesn't take much time. If you just sit tonight, you can finish it tonight. Just, but it is going to help you regardless. Like any tech job, Jupyter Notebook, and then how to publish your Jupyter Notebook. It is very important skill these days, because we do a lot of hard things, but sometimes we become lazy in certain things which are important for business or presentation side. So that's why I want you guys to become better on the presentation side. You guys are good students, I'm sure, but the thing is, if you can demonstrate your skills in a way, you can leverage maximum of your skills.
So the deadline is on Friday.
Yeah.
The question, so is the assignment is to share what we did today on our GitHub profile?
Like sharing what? The Jupyter Notebook?
No, he's asking, is the assignment is to share what we did today on our GitHub profile?
Yeah. So the assignment is like you create your GitHub account, and then you complete this model, right? You have the Python script already. What you need to do is to create a Jupyter Notebook. I showed you here. If you open a Jupyter Notebook, how do you open the Jupyter Notebook? From a terminal. I don't know. I'm using Mac, but you can use something else. So if you just type in Jupyter Notebook, it opens up a Jupyter Notebook. Okay.
Do you want to share the screen?
Okay. Yeah, I think that will be better. Let me show you. Share screen. So let's see. So guys, I was telling you that how you open, right? So once you install Jupyter Notebook, for example, in Mac, you install Jupyter Notebook, or you can just Google how to install Jupyter Notebook on Windows or Mac or Linux, whatever, Ubuntu. Once you have that, install it. You just type Jupyter Notebook. So it takes you to browser. You're typing in a terminal, but it opens up a browser. Now, say in your case, you may not have any file, so you want to create a new file, okay? Or if you have any already Jupyter Notebook, somebody gives you or I gave it to you, you can upload like clicking here. But for our case, let's say for your case, you want to create a new Jupyter notebook. So you press new here, and then press on the Python 3 kernel or whatever kernel you have, and then it opens up this interface. Once you have this interface, you can go and actually use for example, this code, right? You can copy and paste basically. Just copy and paste. Press enter, and if you press run, it will run. Let's wait. So it is showing some error because I missed some missing stuff because I didn't paste the entire code. But the way you do it, this is how you go. Okay. And then once you do this, you can save this file, save as, and then enter the notebook path and everything. You guys can do the rest of the thing. So this is the part of the homework. You create this Jupyter notebook and then upload in your GitHub account. And also install Voila and link it with your Jupyter notebook. Voila is a little tricky. So if you don't know, I mean, I think YouTube help also how to install Voila. If you still cannot figure out, reach out to us, through Tasnuva or Dean. They can help. I mean, they will reach out to me. I'll follow up there. All right.
So we will be sharing, actually at the end of this session, I will send a post-webinar form of Google form to get some constructive feedback from you. And also you will be able to use the same email and just reach out to us if you have any question, if you are facing any kind of difficulties with the homework, and you'll be able to just reach out to us with that email.
Yeah.
So, yeah, and that post-webinar feedback form is very important so that we know what can we do better in future and what you want to hear from us. Okay, so there's a question from Shovan. May I know the source of the data set?
Yeah, so this data set is you can find online. So it's a free open source data set. It's not like my data set.
So do you want to share the link?
I will, let me see if I find it. I will send it to you. But I mean, you have the data set either way. Let me see if I have this.
Okay. And I think there's one question that was asked a little earlier by Minhazul.
Okay, so what is confusion matrix? Somebody asked. Is he still here or left? But anyway, I'll answer. So okay, somebody asked what is confusion matrix, right? So let me.
Yeah, Minhajul asked for to explain what is the confusion matrix.
Yeah, so let me show you what is. So confusion matrix is nothing but it gives you the number of counts of errors versus correct results. How many counts it is predicting in correct way? Because it's not 100% correct, right? As you see, 86% accuracy, right? So it will predict some value as wrong. It will identify as false positive, some as false negative. So confusion matrix identifies which is the correct value. So 34, it identified 34 correctly, and 7 incorrectly, and second case 5 incorrectly, 45 correctly. So that's what the confusion metric means. Your basically accuracy of the model. How many counts of the data it is predicting accurately or not.
So it's like true false matrix.
Yes, kind of like false positive, false negative, that kind of, yes.
And what does it helps you in when you
well if you want to know how many, say you have one, say in our case 303 data set, right? Or in testing case we have about 100. So from 100, how many it is correct predicting accurately, or do you want in terms of number more accuracy, right? So if you want say 34 plus 45, that's total correct result. If you want even higher accuracy, want to reduce this diagonal 5 and 7, say 1 and 2, you have to improve your model.
Okay. Since we are sharing this, I have a question in this too. When you were sharing it earlier regarding the correlation matrix, the output kind of plot where you had like X and Y axis values together.
This one?
Yeah, this one, yeah.
Yeah, what is the question?
So my question is like, why does the fields in the y-axis is like from top to bottom, comparing it to the fields of x-axis from left to bottom, in left to right in the Fourier semantics? Like in the standard, like a math graph, it's like 0, 0, and I mean you
Well,
see like.
Yeah, but if you do that, it will be, it's the same thing. If you do that, this diagonal matrix diagonal will be plotted along this diagonal.
So that is not a problem. It's
That's
just
not a problem. No, it's just you are interested in the values, the
Okay.
correlation values. Which variable, slope versus resting blood pressure, for example, -0.12. So we want to see that two variables, how they are related, how much coefficient value they have. You can plot in either direction. It's not a problem.
I see. And just to summarize for the homework, we just need to create a Jupyter notebook and follow the Python scripts, run it by line. Create a.
Yeah, I did. Yes. So first create a GitHub account.
Okay.
And then go, so install Jupyter if you don't have. After installing, you go to Jupyter and open Jupyter notebook the way I showed.
Yeah.
And then let's delete this.
Open a new notebook, right?
Open a new notebook here, and then
Run
I think the codes that I have here.
and run it step by step.
Yes.
See the results.
Right.
And then save the notebook and upload it to GitHub.
Exactly. But then the second part is to publish into Voila.
Oh, Voila, yeah. You figure out installing Voila. And
You have to install Voila as well.
So you need to, in the GitHub, after you're done, upload the GitHub notebook, Jupyter notebook, and then upload the Voila report, right?
Yeah, so I mean, Voila is for your purpose. I don't think I can. Yeah, because it is important. Like when you want to share some work of your work with your team members, they want to see remotely in a browser.
Okay.
They don't want to run a Python, script or Jupyter and all this blah blah. They want to see something in a browser, so it is easier for them.
So regarding Voila, I have a question. It creates a local host, but when you share it to remote, like co-workers or some friends.
No, I think you can probably view my result. Okay, so this is Voila. Let's see. If I take it to Voila, you should be able to see it. Let me share the link. I think people left, but I should have said that. But they will know.
So you just need to upload the Jupyter notebook and the GitHub and then submit the URL on the Google form that you give,
yes,
right?
Yes.
Okay.
So the Voila, what I'm saying, like if I give you the link, this link, you should be able to open in your, let's say, what is the chat?
Can we share that? So let me try.
Let's see if it should work.
We are actually running out of time.
Okay. Yeah, I'm good. I'm done. So yeah, let me know if it works or not.
Yeah.
No, it gives me 404 error.
Okay, so I need to activate some sharing option. But you do this for your purpose, okay?
Okay.
And then this is important, Voila part. I have to share, I have to allow sharing some setting.
Okay, got it. Thank you so much for this session. It was wonderful.
No problem. Thank you for joining. I'm sure you guys will have much more to do in future.
Yeah. All right. Thank you. Thank you, everyone, for joining today's webinar. And of course, don't forget to give us some feedback. We really appreciate it. And we hope to see you again in future webinars that Algorithm will host with different experts. And a big thank you to you, Dr. Mamoon, for sharing all of your knowledge and expertise with us.
Thanks, Dane and Tasnova, for helping me.
Yeah.
I was one question to Dean. It's not related to this session. Regarding the writer's session, I tried to sign up and it asked me to confirm the email, but I didn't got the email. So does that mean I'm still enrolled into that webinar?
Don't worry. I'll double check for you and I'll send you an email in regards to that.
Okay.
All right. But yeah, so thank you so much again for everyone who came and stayed all the way through. Have an amazing afternoon and take care.